Hi, my name is Raj Pawate. I work for Cadence Design Systems in the Tensilica IP group. This group designs programmable DSPs for several different types of applications. One portfolio of DSPs called the Hi-Fi is optimized for audio and speech processing applications. Let me first give you the context of this talk. We worked with standard bodies called 3GPP and ITU-T in coming out with a new reference implementation for transmitting voice as well as music, but it would not consume as much battery power as the previous implementations did. So as you all know, mobile phones were initially designed and optimized for transmitting voice that has got a bandwidth of about 3000 hertz. But imagine going to a concert and trying to stream live the performance. The person on the other side will not be able, if you used your existing phone, it would just be transmitting 3000 hertz of bandwidth, whereas the sound from the music and the singing might span the entire 20 kilohertz, and naturally the person on the other end would not have the full audio experience as being there. Instead, if you were to use a phone that leveraged the entire 20 kilohertz, obviously his listening experience would be better. So one such codec that was standardized by 3GPP is called the Enhanced Voice Services Codec EVS. This is a hybrid codec and it leverages the full 20,000 hertz of spectrum. So if the mobile phone were to use this, then the concert, the listening experience at the receiving end would be pretty good. However, this complex codec requires a lot of cycles, and obviously when you are running it on a mobile phone, it will drain the battery life pretty quickly. Imagine having to charge your phone in about 10 minutes when you started recording. That would not be a very pleasant experience. So what I'm going to talk to you now is we came out with something called alternate EVS. This is a more power efficient implementation, and naturally, because it is power efficient, the battery life on your mobile phone can last longer. How did we go about doing this? This is because these standard bodies, for example, ITU-T has something called basic operators that all the reference codecs from 3GPP rely on. We realized that EVS was based on a set of basic operators that were influenced by an earlier generation of DSPs. However, modern DSP architectures have now become prevalent, and these modern DSP architectures have capabilities such as a 64-bit wide accumulator instead of the 40-bit wide accumulator that was assumed, as well as VLIW and SIMD capabilities. So the first thing that we did is we modified the basic operators to leverage these capabilities, and we went to 3GPP first and made that a standard. It became a standard called 26.973, and then we also worked with ITU-T, and they upgraded their G.191 standard, and both of these standards were released in 2019. After this, we worked with the 3GPP SA4 group and changed the reference code, and this new reference code is called the alternate fixed point EVS code. We had to go through extensive quality assessment as well as interoperability tests with members of the SA4 working group before this became a standard called TS 26.452 in 2019 as well. In the future, 3GPP is working on iOS codec, which is meant for AR and virtual reality applications, and we expect this new codec also to make use of this new basic operator set. I wish to acknowledge VoiceAge, in particular Milan Jelinek, Tommy, and Redwan, and also the 3GPP SA4 working group, Chairman Imre Wagra from Qualcomm, as well as all the participating members such as Fraunhofer, Ericsson, Nokia, Orange, NTT, Samsung, LG, Intel, Apple. It was a pleasure to work with the representatives from all of these companies. Thank you.